Okay, so first we're going to look at the blood, and blood comes out of your heart. It enters the aorta, which is that giant blood vessel, the biggest one that you have coming in your body, and part of that is going down into the abdomen as the abdominal aorta, and one of the branches of the abdominal aorta is the renal artery, and in fact there are two. There's a left and a right. One goes to each kidney. So the renal artery is going to enter the kidney. The interlobar arteries come off of that, and then the arcuate arteries, the interlobular arteries, the afferent arterioles, the glomerulus, and then out through the efferent arterioles, the interlobular vein, arcuate veins, interlobar veins, and finally the renal vein, which is going to exit the kidney. So it must be important, right? Because about 25% of your blood goes straight to the kidneys during every cardiac cycle. So every time your heart beats and you pump blood, about a quarter of that blood goes into your kidneys. And I want you to notice up here when we were looking at the flow of the blood of how it was kind of circular. So on one end you see the renal artery, on the other end you see the renal vein. Right next to those you're going to see the interlobar vein and the interlobar arteries. And so if you look at it that way, it makes it easier to remember. Just coming at it from one side and coming at it from the other side are going to be very similar. Make sure that you can distinguish between lobar and lobular. They sound very similar, but they are in fact two different things. And there's one for each, for the veins and the arteries. So when we talked about the cardiovascular system and we came up with a way to remember that arteries carry blood away from the heart, veins carry it towards the heart, we said A for away. And that might trip you up a little bit here, but don't let it, because in this case it's the opposite. A is going towards the glomerulus, and E for efferent we can remember as E for exit, because that's going to be exiting from the glomerulus. And the glomerulus itself is going to contain capillaries, which should make sense to you, right? Because in any flow of blood, we're looking at it from arteries, which goes towards something, right? Because it's carrying oxygenated blood, all the way to veins, which is going to go away from that something, and back to the heart because it's carrying the deoxygenated blood. But in the middle, you're going from large to small. So we went all the way from aorta to these little tiny arteries to arterioles, which are small artery things, into a glomerulus, and then when you came out, Alright, so we've got the blood. Now where's the urine? Well, as the blood is entering your kidney through the afferent arteriole and the glomerulus, and the glomerulus is inside of Bowman's capsule. During that first part of the process, it's being filtered, the blood is, and therefore we're going to call it a filtrate, because it's still blood-like, but it's a filtered form of blood, so it's filtrate. It's then going to enter the nephron, and it's going to go through the nephron all the way from the PCTH through to the collecting duct, and it's not until it leaves the nephron that it actually becomes termed urine. So once it's termed urine, it's going to go through the calyces and the pyramids, through the ureter, and the ureter carries it from the kidney to the bladder. And the bladder is kind of like a storage facility for the most part. It just stays there unchanged until it's ready for excretion. And once it's ready, it's going to head down another tube called the urethra, which is going to take the urine from the bladder and all the way out of the body. So we refer to the urethra as the terminal organ of the urinary system because it's the one that's going to go all the way out. It's the last thing that the urine touches before it leaves the body. So all that talk was about physiology, and the physiology makes sense if you follow the anatomy. By the same token, if you're able to follow the physiology, then the anatomy will make sense as well. And to prove that, we're going to go through kind of the same things we just did, but look at them from a different perspective using pictures instead of words. So here again, we're seeing the renal blood supply, and you can see the renal artery and how it's a fairly decent size, and it's entering into this kidney bean-shaped thing called the kidney. And as it's doing so, it's branching off into these interlobar arteries. And you can imagine that the title of this artery kind of probably got its name due to the fact that the shape of these interlobar arteries kind of divides the kidney into lobes, or things that look like lobes. And then it goes into the arcuate arteries, which are these C-shaped that kind of look like an arc, right? So that makes those easier to remember. And then interlobular arteries. If you think of like arterioles being smaller versions of arteries, then it's easy to imagine that a lobule would be a small version of a lobe. So if these big lobar arteries are making lobes, then these little lobular arteries should be making lobules, right? And then you'll see it going down into the second picture at the bottom, and you get the afferent arterioles going into this Bowman's capsule, which contains the glomerulus and those capillaries, and then out the efferent arteriole, and backwards through interlobular veins, arcuate veins, interlobar veins, and then renal vein. In the renal vein, if you look back at the top picture, you can imagine if right next to the renal artery there was a blue tube that was approximately the same size, that would be the renal vein exiting out and going back towards the heart with the deoxygenated blood.